Toma Tamal, some details the Kungamsa, and Dringi Lobzendi, cousin triangles, decolam, Chick dig it tone, and would test chick and recap and then a congruence of triangle na. And the congruence of triangle ni congruent shape, size, angle, somewhat chick with chiga, injimage gore. And Delaya dupcha triangle ni congruent le kunge yamena chage minda waka shiswa. And dinane, the remote June Jojo Cheng Dux Kuduchi and Tangudella. Triangle ke the triangle ni chikpa chikena chimachishi and the triangle ni digi side kapte corresponding sides level side kapte chikpa chiken yore dende yovena triangle ke angle de shuma thugi triangle angle de ke chikpa legre pechachna ta de triangle dinala side sum angle samangete doa that looks says Chikpachijang triangle the Kevin Digal Shavina triangle dinija identical takta. So these two triangles are congruent. So congruent in a angle chikpajian 60 degree, they 60 degree. Dini Rangdu Chikpachazoa, they 75 degree, they see the 75 degree. They 45 degree. So S triangle ni side Dige kapte takla chikwa na angle de rangshingi chikwa le ngure. So chikche dine niwa dela triangle chignala side chikda angle ni chikwa na anga ngazu chike da inda side chikda angle ni side chikda angle ni la du sane side there, for example this side side is 17 centimeter. This angle is 90 degree. The angle is 50 degree. Chikpachijan chiyang de kiungda. The triangle nija congruent redwa. Ta chidangi triangle ni congruent le. Taki tangbu de SSS side kapte chikpa. De la karke asana. Angle ni the side chick. The yago is sina injimiji angle ni coin did capsule angle ni the coin in digore. Dukes in a digore. This is 40 degree. Side chick included angle included side chain tanigi angle the triangle ni chikbayona. Triangle ni congruent chagri. Doks chikche. Ta niwa dela. Didi chiksida. Didi. Ne dinala ni kati orzana. Angle sumjata 90 degree, 50 degree, 40 degree. Triangle dini dada. Triangle dini congruent redwe. These two triangles are not congruent. Yagoshtada triangle jijungora kevadwa. The yime corresponding angle chikbayar 40 degree, 50 degree, they 50 degree, 90 degree. But then triangle need they are not congruent. Corresponding angle chikbayina triangle need the congruent neighbor kevkumare. The example chik. The example shandaji yan that 50 degree, 40 degree, and 90 degree. You may know that two triangles are not congruent. This triangle is much smaller than this given triangle. Okay. Now, the triangle denale. Take it the example dini angle sumja te angle sumja chikbayona. So 70 degree, 70 degree, 50 degree, 50 degree, 60 degree. But then these two triangles are not congruent. So corresponding angle chikpa, the two triangles will not necessarily be congruent. It can be congruent. Example is this one. The example ki thone congruent likdoa. Congruent le the chajing gardo corresponding sides are equal. But here corresponding sides are not equal. This triangle is much smaller than this triangle. Okay. And then the last one. If this is S, one side, okay, two sides are given, and one angle, you can write it SSA or ASS. Today, even now to see the 12 centimeter, 12 centimeter, they are equal. 15 centimeter, 15 centimeter, they are equal. One each angle are equal, 50 degree, 50 degree, but these two triangles are not congruent. Let me check. Tada. 12 centimeter, 12 centimeter, and 15 centimeter. But then triangle near the congruent remedy, this triangle is much smaller than this triangle. Okay, so if any two sides and an angle of one triangle is equal to any two sides and an angle of other triangle, the two triangles may not necessarily be a congruent triangle. So today we are going to discuss the proof of one of the congruence rule. First let me recall some of the congruence rule. The first one is side, 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 and then angle, side, angle, or you can say the first one is side, angle, side, 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 angle, side, angle, and this is for right triangle. Okay, so now earlier we studied about axiom and theorem. So today we'll use one of these rules as axiom. We shall take this as the axiom. If any two sides and an included angle of one triangle is equal to two sides and included angle of the other triangle, then the two triangles are congruent. So let's assume that this is true. So things which we do not prove but we assume them to be correct, we call it axiom. And then second, using the axiom or universally accepted truth as a base, we prove, if we prove another statement, that we call it a theorem. Theorem di axiom di shishav SAS shishav tone theorem di prove cheyenda. Theorem dina gari if two angles and an included side of one triangle is equal to two angles and included side of another triangle, then these two triangles are congruent to each other using this axiom or congruence rule. So let's look at the statement. Two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. So we have two triangles, triangle ABC and triangle DEF. F. In these two triangles, two angles, angle B is equal to angle E, and angle C is equal to angle F. And included side in this case is BC. In this case, included side is EF. These two sides are equal. If that is the condition, then the two triangles will be congruent. So for that, let's prove. When we prove theorem, we follow certain basic steps. The first one is, this is a statement. We write the given. What are the given in the question? In the question, you are given two triangles. In these two triangles, two angles are equal and one included sides are equal. So in triangle ABC and triangle DEF, in these two triangles, angle B is equal to angle E and angle C is equal to angle F. Between these two angles, this is the included side. Side BC is equal to side EF. Now, this is the given. So, next, what we have to prove or what we have to show that triangle ABC is congruent to triangle DEF. So, to prove is triangle ABC is, this is a sign of congruent. Triangle ABC is congruent to triangle DEF. Okay. Now we have the proof. So in this case, three cases arises. Three cases arise. So we shall discuss one by one. Case 1. Now case 1, let us assume let AB is equal to DE. Then now we'll see whether this triangle ABC and DEF are congruent or not. Then in triangle ABC and triangle DEF, AB is equal to DE. Now this is our assumption. We assume that they are equal. So this is assumed value. We assume that these two are equal. And then angle B is equal to angle E. Why? Because in the question, these two angles are given equal. Let's look at the given. Yes. Angle B is equal to angle E. So the reason is it's given in the statement or the question. And next, side BC is also equal to side EF. That is also given in the question. Now look, the three conditions. Two sides and one included angles, or one triangle is equal to two sides and included angle of the other triangle. Therefore, triangle ABC is congruent to triangle DEF. And this is by SAS axiom. We call it by SAS axiom or by SAS congruence rule. So this is the first case. Okay, next. case number 2. Suppose AB and DE are not equal. Then what will happen? AB may be greater than DE, or DE may be greater than AB. So in the second case, we shall take let AB, if they are not equal, then one of them should be greater than the other. So let AB is greater than DE. So if AB is greater than DE, then we'll find a point on AB so that, let's say A dash B will be equal to DE. So take a point A dash such that A dash B is equal to DE. Okay, now let's check whether this new triangle and this given triangle DEF are congruent or not. So in triangle, instead of ABC, we'll call it triangle A dash BC and triangle DEF. Here A dash B is equal to DE. Why? We construct them equal. That is by construction. CONT, right? ST. This is short form of, let's call it short form of construction. Second, angle B is equal to angle E, which is given in the question. In the question, they are given equal. And third one is BC. Side BC is equal to side EF. So that is also given in the question. So what we'll find? We'll find that these two triangles are congruent. Therefore, triangle A dash BC is congruent to triangle DEF. Why? By using the rule SAS. We can call it by SAS rule or congruence rule or by SAS exam. Okay. If two triangles are congruent, then what we'll conclude? We'll conclude that corresponding parts are equal. But when I say corresponding part, it may be side or angle. In this case, we'll take up angle. Therefore, angle A dash CB, this angle, is equal to angle F. Why? This is CPCT. Corresponding part of congruent triangles are equal. Right? So these two angles are equal, but you are given that angle C is equal to angle F in the question. That is given. So which means both angles A dash CB and angle C should be equal because both of them are equal to angle F. Therefore, we conclude that angle A dash CB is equal to angle F. Right. Now, is this possible? So this will be possible. These two angles will be equal if this A dash coincide with A, right? Is this possible? This is possible if A dash coincides with A. In that case, then what we'll get? We will get AB is equal to DE, right? If A dash and A coincide, then A B will be equal to DE. So in this case, what will happen? We'll get, therefore, triangle ABC will be congruent to triangle DEF. Earlier we have A dash. Now we have seen that A dash and A are not two different points, but they are the same point. So the reason they are congruent, why? Because two sides and one included angles are equal by SAS rule. Okay, and the last case number 3. So if let's say like AB is less than DE. So if I say AB is less than DE, it also means DE is greater than AB. So we follow the same procedure of case 2 with this. Here what do you do? If DE is greater than AB, we shall find a point D dash on DE so that A dash E will be equal to AB. And then we repeat the same procedure and we'll come to the conclusion that again triangle ABC is congruent to triangle DEF. Okay, let me quickly do the last part. Take a point D dash on DE such that D dash E is equal to AB. Okay, now in triangle ABC and triangle D dash EF, AB is equal to D dash E. Now this is by construction, right? And angle B is equal to angle E given. BC, side BC is equal to side EF. That is also given. So therefore, triangle ABC is congruent to triangle D dash EF by the same congruence rule, by SAS. So these two triangles are congruent, and if these two triangles are congruent, then corresponding angles are equal. Therefore, angle C is equal to angle D dash F E, CPCT. Okay, but you are given that angle C is equal to angle F. So therefore, angle D dash FE should be equal to angle F, right? Angle D dash FE is equal to F. Now, the same question arises. Is this possible? Now, this will be possible if, again, same, D dash coincides with D. So if D dash coincide with D, then AB will be equal to DE. So hence triangle ABC is congruent to triangle DEF. Earlier we have taken triangle A-BC, but we have come to the conclusion that triangle A-BC are same as triangle ABC. Hence, triangle ABC is congruent to triangle DF. So this is the congruence rule, ASA rule. Thank you.